Hey Econ 200, in this video I'm going to discuss answers to problems from Chapter 8. I'm going to talk about two of the problems in Facts and Tools. Those are problems number 2 and 7. I'm also going to talk about two of the problems from the Thinking and Problem Solving section, which are problems 2 and 16. So let's get into it. Facts and Tools, problem number 2. When a price ceiling is in place keeping the price below the market price, what's larger, quantity demanded or quantity supplied? How does this explain the long lines and wasteful searches we see in price-controlled markets? Well, let's illustrate the answer with our old friend, the supply and demand graph. All right, so here we have supply and demand. The equilibrium price would be up here, but we're talking about a price ceiling. So that ceiling is going to hold the price below the equilibrium price. I call that price P bar. And it asks, in this case, what is greater, quantity supplied or quantity demanded? Well, quantity supplied is just where this price hits the supply curve. Quantity demanded is where it hits the demand curve. And as you can see, quantity demanded is greater than quantity supplied. In other words, at this price, buyers want to buy more units than sellers are willing to sell. Now, how does this explain the long lines and the search costs? Well, if there are fewer units to go around than there are people who want to buy them, then those people, and more than that, these people who want to buy those units are not legally allowed to pay more for them. Okay? They cannot compete the price up. They're going to have to compete with each other in other ways. One of the ways of competing with each other is just show up early, right? Be at the location where you could buy that product before the other buyers get there. That would explain why you get these long lines, right? As people rush to show up to be the first ones in line. Or also just have the stamina and the endurance to stay in line and wait till you get to the front to purchase the product. And also search costs. If you're more willing to go out hunting for people who are selling this product, you're more likely to be one of the ones who gets the product. Okay, so the fact that there are more buyers than there are sellers, or at least buyers want to buy more units than sellers are willing to sell, that and the fact that the buyers can't compete price up, that's what drives them into the long lines and incurring search costs. Facts and Tools, problem 7. Price controls distribute resources in many unintended ways. In the following cases, who will probably spend more time waiting in line to get scarce price-controlled goods? Choose one from each pair. Basic idea of the correct answer to each of these pairs is whichever of the two groups of people would have the lower cost of waiting, the lower cost of searching for the product, they're the ones who are going to be more likely to be in line. Okay? So part A says working people or retired people, which would be more likely to wait in line? Well, the answer is going to be retired people. Retired people have, on average, more spare time than working people do. If you've got a job, that's 8 to 10 hours of your day that, at least theoretically speaking, you're not allowed to be waiting in line. Whereas a retired person does not have a job competing for, or an employer competing for their time over standing in line waiting for the product. Okay, I'm not sure if I put this in the answer key, but I had a friend in graduate school who grew up in, I believe, Bulgaria, where they lived under a massive price control scheme. And according to him, once a family member retired, they got a new job, which was waiting in line for the family. Okay, the family would say, look, you don't have a job to go to, so you can't earn money to improve the economic well-being of our family. But what you do have is spare time, and now you're going to use that spare time waiting in line to spend the money that the rest of us are earning at our jobs. Part B, who's more likely to be waiting in line? Lawyers who charge $800 per hour, or fast food employees who earn $8 per hour? Well, your wage is an opportunity cost. Every hour that lawyer is spending in line is $800 that he's not earning, whereas every hour that a fast food employee stands in line is $8 that he is not earning. The lawyer has the higher opportunity cost and therefore is less likely to spend much time in line. Okay? In fact, what's more likely to happen is lawyers who earn $800 an hour are going to go out and find people who have lower opportunity costs, like fast food workers or possibly even homeless people, have them stand in line for them and purchase the product and just pay that person, right? If I'm making $800 an hour and I find somebody who could earn $8 an hour preparing fast food, I could offer to pay that person $10 an hour to wait in line for me and to give me the product once they purchase it. So you're more likely to see lower wage people waiting in line than higher wage people. Part C, people with desk jobs or people who can disappear for a couple of hours during the day. Well, once again, it should be pretty obvious that it's going to be the people who have more flexible time and a lower opportunity cost there. A person who can disappear from their job for a few hours a day is a little bit like a retired person. Not completely, because they do have to show up to the job for some amount of time. But a person who's chained to their desk for the full 8 to 10 hours that they're supposed to be in the office, obviously they're going to have less spare time and therefore a higher opportunity cost of waiting in line than somebody whose job offers them some flexibility where they could dart out for a little bit. Okay, so that's the answer to problem 7, or those are the answers to problem 7. Let's move on to thinking and problem solving. And we're going to begin with problem 2. I'm going to erase the board to make space for that. Okay, thinking and problem solving. Problem number 2. When the United States had price controls on oil and gasoline, some parts of the United States had a lot of heating oil, while other states had long lines. As in the chapter, let's assume that winter oil demand is higher in New Jersey than in California. That's what I've got on the board here. We've got similar supply curves right now in both markets, California and New Jersey, but demand is lower. It's down, it's lower and farther to the left in California than it is in New Jersey. If there had been no price controls, what would have happened to the prices of heating oil in New Jersey and in California, and how would greedy, quote-unquote, greedy business people have responded to these price differences? All right, so in a world with no price controls, where the intersection of supply and demand determines the price, what you would have would be a situation like this, where California has a relatively low equilibrium price, and New Jersey has a relatively high equilibrium price, okay? But the story wouldn't end there, because this presents a profit opportunity for the quote-unquote greedy business people. What is that? It's to say, well, look, people in California don't care very much about heating oil in the winter because it doesn't get all that cold out here in California, and so I can buy oil cheaply in California, and I can supply it relatively. I can sell it at a higher price in New Jersey. This is a profit opportunity for me. So if I can buy it here for, say, $10 and sell it in New Jersey for $20, well, then I have a financial and economic incentive to do that, to move the resource from where it is valued less to where it is valued more. Now, ignore for the moment any transportation costs between California and New Jersey. What would you expect to happen? Well, you're going to have some people buying up oil in California, which is going to shift demand for oil in California to the right, okay, which is going to raise the price in California. They will then take some of that oil and supply it, sell it in New Jersey, which is going to shift the supply curve down. So prices will be going up in California. They will simultaneously be going down in New Jersey. And if there were no transportation costs from moving across the coast, that would happen until the two prices were equal to each other, until you had raised the price in California enough and lowered the price in New Jersey enough that they were exactly equal and there was no profit opportunity left to move oil across the country. Okay? Now, if there are transportation costs, and of course in the real world there are, you would expect that process to happen until the prices were close enough that the difference in prices was exactly equal to the cost of transporting oil from one location to the other. But what matters really for answering this problem, if something like this showed up on the midterm exam, would just be to note that there is a profit opportunity if the prices can change. Okay, that low prices in California, coupled with high prices in New Jersey, is going to incentivize people to move the resources from where they're valued less to where they're valued more. Okay. All right, with problem 16, you're given a graph that looks like this, except the lines are straighter. And the problem asks the following. In the market depicted in the figure, there is either a price ceiling or a price floor. Surprisingly, it doesn't matter which one it is, whether it's an $80 price floor or a $30 price ceiling. The chart looks the same. In the chart, there is a rectangle and a triangle. One represents the value from the value lost from deals that don't get made, and one represents the value lost from deals that do get made. Which is which? And there's one thing that I neglected to put up here, which is they label the rectangle A and the triangle B. Okay, so which of these represents value lost from deals that do get made and deals that don't get made? Let's start with the deals that don't get made. We know that if you impose either a price ceiling or a price floor, the number of transactions in this market is going to drop from 200 to 100. Why is that? Because in this graph, if you hold the price artificially low at $30, sellers won't be willing to sell more than 100 units. Or if you hold the price artificially high at $80, buyers won't be willing to buy more than 100 units. So in either case, you get the same quantity of 100 units. In equilibrium, there would be 200 units. And so the price ceiling or the price floor cuts the number of transactions in half in this particular case. And that means this area, B, that's going to be a deadweight loss because these transactions won't happen. Okay? In other words, that is the value lost from the deals that don't get made, because you're stopping the trades here at 100 when in equilibrium you could have 200. That means, of course, by process of elimination, A must be the value lost from the deals that do get made. How could there be value lost from the deals that do get made? Well, let's start by thinking about price ceilings, and then we'll think about price floors. In the case of a price ceiling, the way that this rectangle could end up being wasted is if the buyers all spend their time in line. If there are no, what would you say? If there are no bribes or side payments or anything like that, or black markets, so that everybody, all the buyers just wait patiently in line until they either get the product or don't get the product. In that case, this rectangle represents the value of their wasted time. Remember that they are willing to stand in line until the dollar price that they pay plus the time price that they pay is equal to, in this case, $80. Okay? And so they would be, remember that time price is a price that doesn't get transferred to the seller. They can't, whereas with a bribe, I can take 50 of my dollars and offer them to the seller and say, look, I'll pay you this bribe in addition to the price to give the product to me. Well, if this $50 represents a time price, I don't get to give the seller my time. I only get to give him the $30 price. Okay, so that $50 is lost to me, but it's not gained by anybody else. And so that becomes the cost or the loss of a deal that does get made. And if you add those up across all the 100 transactions that would occur, this area A is going to be the value lost from the trades that do get made. What about if you have a price floor? Well, remember that with a price floor, the sellers are now willing to spend extra money on quality upgrades in excess of the value of those quality upgrades to the consumers themselves. And in the extreme, these sellers would be willing to spend an extra $50 per per buyer in basically wasted quality upgrades. They'd be willing to spend $50 more in quality upgrades than whatever price the buyer would be willing to pay extra for those quality upgrades. And so that is a waste of resources, okay? And so that would also turn this rectangle labeled A into value lost from the deals that do get made. So it's either wasted time if it's the buyers, or it's wasted resources if it is the wasted quality resources if it's the sellers. All right. So that is the answer to problem 16, and that does it for chapter 8. Hope this was helpful, and if there were any problems from chapter 8 that I didn't get to that you were very confused on, please feel free to contact me and set up a meeting. I'll be happy to talk to you about any of them. All right, thanks. Take care, guys.